I am a client executive here at Covenant Technology Partners. Very excited for today's Copilot webinar around computer use. We feel that this is a very topical subject for a lot of our clients as of late. For those of you who are not familiar with Covenant Technology Partners, we're a premier Microsoft consulting firm. We're headquartered in St. Louis, Missouri. We've been a dedicated Microsoft-only partner for 21 years now, and we're fully credentialed in many of the areas. AI and Copilot have been a couple of areas that we've been early adopters as far as Microsoft partner goes. Fully certified for their partner funding around AI and Copilot, building agents at scale for organizations we partner with things like Agent Factory, AI Foundry, and Copilot Studio. So happy to take any of those needs offline as they may be appropriate. Quick housekeeping note, if you do have questions, this is only an hour session, so just please put them in the chat and we'll make sure that they all get addressed at the end. We are also recording this. We will send out the recording to all attendees after the meeting, and then we'll also send out the presentation slides as well after the meeting. So with that, I will turn it over to our certified Microsoft AI MVP, Kurt Rowland.
Thank you, Martin. Let me get my screen shared here for everyone. Well, good morning, good afternoon, and good evening, depending on wherever you're dialing in from. My name is Kurt Rowland. I'm with Covenant Technology Partners. I'm a principal AI architect. I have included here my QR code as well as my LinkedIn profile if you'd like to connect with me and follow up. Obviously, you can also follow up, as was mentioned, through Martin and the team here. As Martin mentioned, I'm a Microsoft MVP and MCT. I specialize in Copilot and agentic architectures on the Microsoft platform. I'm also PMI certified in cognitive project management and a project management professional. So glad you could join us today. Our quick agenda, we've got an hour, but I think it'll go pretty quickly. We have a lot of material to cover. We're going to talk first of all about the automation opportunity that you have with Copilot Studio and specifically developing agents. So we'll be focusing on a new feature that's been introduced by Microsoft called computer use. We'll also touch a little bit on agent flows, which brings together the Power Automate capability into the Copilot Studio agent authoring canvas. So Microsoft is positioning Copilot as the AI UI for AI, and what that really means is that if you're running in the Microsoft 365 environment, you will typically get access to your agents through a number of different ways. It might be through what's called Copilot Chat. If your agents get published there, they may also be published through Teams channels, or may also be available through your SharePoint environment. But in most cases, the agent ability, at least to run the agents, if you will, or engage the agents, will happen through Copilot on the M365 platform. And as you look at this slide here, what we're seeing is the Copilot interface here, which is shown on the left, which the user's interacting with, which is the main surface, the agent surface that you would be running the agent from. It's backed by Copilot Studio. And again, Copilot Studio comes in two flavors, a light version for end user development and a heavier weight version for IT pros and kind of more sophisticated business users and perhaps even some low-code developers. And then as you can see to the far right, the agent ecosystem then is available through these surfaces here. Just a quick review on the different kinds of agents that Microsoft currently supports. Starting at the far left, we have what are called retrieval or rule-based agents. These are typically read-only agents that follow predefined instructions or rules and guidelines. The most common scenario of this might be an HR agent, say a Ask HR or an HR policy agent, one that might be used by the employees within an organization, let's say to consult time off policy. Moving to the middle core there, the task-based agents take the retrieval capability and add tasks or the ability to perform particular options within the agent itself. So an example here might be, let's say, extending the HR agent, hypothetically. The user, the end user, might be able to go out and consult, for example, a time off policy, but then what they may want to do then is go ahead and perhaps book some time off, which they could include that capability in the agent, the instruction set in the agent. If the agent had the ability to perform those tasks, it might go out to a Workday system or some other back-end HR ERP system to actually perform that time off task request. And then moving to the far right, we have what are called autonomous agents or dynamic agents. These are agents that will operate more or less independently using instruction sets. So these may be operating, let's say, based on, for example, using our scenario, an HR request for time off may come through, and that particular request from that backend system may, in fact, start another agent, which may, for example, take that information, update the time off calendar, let's say, within the organization. So if you have a vacation calendar, if that time off request gets approved through the HR system, the agent may then take that affirmative acceptance, if you will, and based on that, then go and add an entry to that individual's time off calendar, maybe the overall organizational time off calendar, using an M365, say, Outlook or event connector. So this is an interesting statistic here. The point here is that much of the time that employees spend doing different things within an organization is actually automatable with existing technology, using workflows, using other forms of automation, for example. So, the number is pretty significant in terms of, what could be actually moved from an on-task step, if you will, that people are doing on a day-to-day basis and moving that into either automation or agentic architectures. Here's an example of a seller, someone who's in sales, and the amount of time that is spent prospecting in a typical month, let's say, a portion of that, for example, of that 14%, might actually get translated into an agent if, for example, there was a prospecting agent that was developed. So now what you have is you have an agent that's working, let's say, full time, taking a particular percentage of a prospecting workload off of the seller, which again is a manual activity. Here's some different automation opportunities that might exist in the organization. Starting to the far left, we've got front office around sales, finance, these kinds of functions. We've got customer experience, customer service functions, for example, being able to take in market data, e-commerce. A lot of these things might be around autonomous agents, for example, that operate, based on some different updates, for example, that may happen within these different systems. We've got employee experience. We talked a little bit about HR, for example. A lot of this is around employee self-service. So things like onboarding and offboarding employees, could be optimized using agents. Learning and development, if you're tracking the employee maturation or learning paths within the organization, you may incorporate agents, for example, to perhaps remind employees of the next learning paths they may take, provide them updates. On the manufacturing side, we've got suppliers and partners around supply chain and manufacturing. And then back office, again, would be some key back office operations like quote to cash, for example, IT service and security ops, legal and risk. Again, incorporating agents or other security postures, for example, to help govern and set guardrails in the back office. These are just some published process improvements just within Microsoft in terms of how they have experienced AI and the cost savings that they have experienced by different departments or functional roles. So you can see here that in some of these, like HR, for example, 42%, that's pretty significant. So you're doing a couple things. You're moving the agentic architecture into a self-serve role completely. So the HR folks perhaps aren't even involved or maybe very less involved in that interaction. We've got finance at 60%, like a quote to cash, for example, or cash collections with AR, marketing in terms of conversion rates and so forth. So lots of interesting information here for Microsoft, at least. So what is Copilot Studio? Copilot Studio is Microsoft's primary low-code authoring platform for building custom AI agents. So if we think about what Microsoft is offering today as it relates to agents, quickly they're offering many out-of-the-box agents. For example, there's a reasoning agent, there's an analytical agent, there are prompt-based agents, there are coaching agents, there are a number of different agents that you can actually use that Microsoft offers as basically kind of third-party applications that are available in the environment. Along with that, you can create custom agents, and the way you would do that, again, would be using Microsoft Copilot Studio. And again, as I mentioned, there's really two flavors. There's a light version, and there is a kind of a pro version that can be used by more sophisticated agent creators. If we look at how the different functions stack together here, as we noted at the beginning, since Copilot is the UI for AI, notice at the top, everything really kind of gets expressed through Microsoft 365 Copilot, or at least Copilot Chat within M365. We see in the middle here the Microsoft Copilot Studio, again, which is the low-code or no-code ability or way to build agents. And then at the bottom, we have Microsoft AI Foundry, which is a pro-code development platform that allows you to build and manage agents. We're going to be focusing on the Microsoft Copilot Studio option here. So when we look at agents, we've got really a couple of different levels of autonomy, so to speak. And so what we're really talking about here is this idea of predictive versus descriptive elements in terms of how the agent acts. So when we have something that's an agentic workflow, for example, what we'd like to try to do is use a combination of generative AI, which is a kind of a predictive response to how an agent should work, and couple it with some level of descriptive steps that one might outline in a workflow. On the far right, we have a fully autonomous agent, where what we're going to be doing is we're going to be relying mostly on the cognitive or the predictive aspects. But what we'd like to do is in situations where we need to have a what's called a HITL or a human in the middle, or a human in the loop, the agent can reach out and get additional information, approvals, and so forth to allow the agent to perform the actions more or less autonomously, not completely autonomously, but in situations where we need to have guardrails, for example, we can actually have the autonomous agent reach out to a human to consult what the next step should be in that activity. So when we look at Copilot Studio, again, what we have is we have a canvas or platform that allows us to build agents in a number of different ways. We've mentioned autonomous triggers. Those can be defined and developed within the Copilot Studio environment. And through that, we can, in fact, automate long-running processes. Now, the processes themselves would not actually be running in Studio necessarily. They would be running through something called agent flows, which is really a kind of a variation of the Power Automate platform, which is brought into Copilot Studio. We know because of the large language model capability of the generative AI that we can dynamically reason over information. This would be the prompt. This would be the knowledge that's supplied within the Copilot Studio agent. We also know that the agent can learn and improve over time. This happens through the context of the conversation log, which is kept within the agent conversation based on the particular user. As was mentioned earlier, we can set human guardrails in situations where we want more of a supervisory function over the agent, and we can direct the agent to actually reach out and ask for human involvement or human help when it runs into a situation that requires it. Then we can also orchestrate multiple agents within the Copilot Studio platform. And with that, what we really mean to say is we may have a cluster of agents that come together to support, let's say, a business process. And the different agents might have domain specificity or domain knowledge specifically. So, what you may have a typical architectural pattern might be that you have a manager agent of some kind. Let's go back to our HR example. Perhaps what we have is we have a managing agent called Ask HR. And within that, we have a number of different capabilities we want to support for our employees. One might be to ask HR about time off. One may be to actually process a time off request, for example. Each of these may be independent agents that perform a very specific or unique functions. And so the Ask HR agent might be the overall manager or supervisor that basically directs or delegates work out to the different child agents based on the context and the prompt. This is just a kind of a map overall that kind of shows you how the different pieces and parts of Copilot Studio come together. Many of these are features or functions within Copilot Studio. So if we look at the far left, we see that Copilot Studio has something called an orchestrator. The orchestrator basically keeps track. It's kind of the traffic cop. It keeps track of the prompts, the conversations, the delegation to agents, these sorts of things based on descriptions and instructions that are given to either the agents or the tools. So it's really the overall puppet master, if you will. And then breaking down the different capabilities with the Copilot Studio, we have knowledge. So knowledge is where you would specify where the agent should be going or getting the very specific knowledge it needs in order to process the request. So this might be websites, it might be SharePoint sites or document libraries. It may be connectors to some backend systems. Some of these are mentioned or shown down below in this list here. So you could, for example, connect to Dataverse, or you could connect to files in OneDrive and so forth. So these are just different connect points that you can use to bring knowledge into your agent. We have the tools then to the far right. And so the tools are the way that you can actually apply certain skills to your agent. So the connectors allow you to get to different data points. The flow would be the agent flow capability to be able to write a workflow that's connected to your agent. We have the prompt tool that allows you to basically transform prompts within the context of the agent. We have the model context protocol, the MCP servers. We'll touch on that a bit. We have computer use, which is actually the focus of this presentation. And then we have a REST API that allows you to get to third-party systems through an OpenAI specification. And then we can also connect to agents on other platforms. For example, if we want to connect to an agent in AI Foundry or Fabric Data Agent, we could do that as well. Again, talking about agent flows, again, this capability brings in these deterministic workflows right into Copilot Studio. So, if you want to, let's say, for example, based on a particular step in an agent, you'd like to be able to perhaps send an email off to a particular user, based on a particular status or response within the agent. You could write a workflow to do that. What you would do is you would go in, and you can see here, this screen here, we have an instruction set where we're actually connecting to tools and calling an agent flow in a particular situation. So that agent flow may in fact go out, and you can see here, we've got the Office 365 Outlook connector. We may be able to send an email, for example, out to a particular user, or perhaps even update a record in a database. We have autonomous agents. Again, these are acting independently or autonomously based on triggers. So as you can see here, we can add a trigger within Copilot Studio. Based on the trigger that gets added, then we can then perform, different actions or certain actions. There are a number of different trigger points that can be added. It could be, again, databases. It could be, let's say, receiving an email. It could be, let's say, a Microsoft form being submitted. Lots of different things that can actually trigger an agent, an autonomous agent. So we talked a bit about the MCP, or the Model Context Protocol. So MCP is a standard way to connect to agents. Connect your agents to data and tools. This has moved from a preview mode to now becoming generally available in Copilot Studio. And essentially what you do is you create a tool and you select MCP as the tool provider, and then you can select from a number of different built-in MCP connectors. This is really just a very standard way of accessing a service outside of M365. And generally speaking, you have the ability to access both knowledge and tasks, depending on how the MCP server is implemented. A note here too that there is actually a growing marketplace of MCP servers that can be utilized. And these connectors, again, generally speaking, are actually maintained by the third-party vendors. We'll actually be using an MCP server for computer use. That's actually how that's implemented. Here's some visuals here, just giving you an idea of before MCP. In other words, how would an agent work before MCP and after MCP? So as you can see on the left, the agent would essentially have to map the functions and the data from each individual API endpoint into the agent. So as you can see here on the left, we might have 3 different connectors, for example, or 3 different REST APIs that have to be consulted by the agent and consulted with the large language model. Over to the right, since the Model Context Protocol is a unified API, what we could theoretically have is a single server, which then incorporates a number of different services. And so this in-between point essentially gives a single point to the large language model with regards to accessing both data and functions. So it really very much streamlines the agent building process. This particular visual gives you a little bit of an analogy with regards to how MCP looks, and the reason why it's extremely kind of helpful. It's almost a plug and play. What we have here is we're using a computer hardware analogy. We have a computer notebook here at the top, and as you can see that the MCP servers are kind of like USBs that plug into a standard port. Now, each USB device performs different functions. So if you think from a hardware perspective, I may have a USB device that's a hard drive. I may have another that's a scanner or printer or whatever. They all use the same standard connector, that being the USB-C, right? But each device provides different kinds of functionality. The point is that the MCP bus, or in this case, the MCP server, knows how to talk to each individual device and request or consult what the different features and capabilities are of those particular devices, and then offer them back, in this case, to the MCP host, which for us would be Copilot Studio. In the hardware analogy, obviously it's the computer. It's the hardware computer itself, which would benefit from the hard drive, the scanner, and so forth. So it's really meant to be a kind of a plug and play model here. We covered this a little bit deeper dive here in terms of the different tool options in Copilot Studio. As you can see, we have prompts. So with prompts, what we're able to do is develop independent prompt tools that we can use to actually process prompting and essentially generate new prompts based on things like replaceable parameters or variables. And so, what this may mean is that a user may input prompt A in terms of what they're requesting, right? Which may be relatively rudimentary, but using our own prompt tools, what we can do is we can transform that into something much more, how can I say, complex, or much more fully defined, that can be used then against a particular, connector, MCP server, whatever, to get a much better result. We have connectors again. The connectors have been on the Power Platform the standard way of getting access to external data and functions. We have those supported. We have deep reasoning agents now, which are available to us. This is really an option here that can be set in Copilot Studio, which enables what's called a multi-turn reasoning capability that gets added into your Copilot Studio large language model. We have the model context protocol, which we've talked about. We have the code interpreter. Now, the code interpreter is actually the ability to write Python code and integrate that into your Copilot Studio agent. And one of the distinct advantages to that is that with Python, you can perform or create real-time graphing and charting. So if you have situations with your Copilot Studio agent where you'd like to be able to take the data and develop a visual for it, you could use the Python code interpreter tool to be able to do that and actually embed that result right within the conversation. We have a couple of other tools here. We have document generation, and of course, we mentioned the REST API. So, when we look at creating an agent and many of the different things that we want to perform, we're using kind of an iceberg metaphor here. We find or think that we have a particular surface area, if you will, of capability that we need to be able to develop with our agent. But what we find is, as we dig more deeply into the agent, we find that there are more and more tools and capabilities that we need to engage. And so the idea here is that the area underneath the glacier, if you will, the iceberg, is much larger than what we see on the top. The point here is that because Copilot Studio is such a flexible and powerful tool, it's fairly straightforward to add additional capabilities to it through the tooling to be able to give us a much more fully functional end result. All right, well, let's jump in quickly to computer use specifically. So I'm going to note first off that this is still in preview. So while it's available with your tenant, for example, it is in preview mode, so you may find that you get different results based on what you're doing, number one, but number two, obviously, just the kind of fact that this isn't a pre-release or preview mode. So we'll walk through some of these screens quickly here, but basically the steps are, you go in, you create your agent, and then you select a computer use tool. And then from there, you go ahead and you build out the instructions on how you want the tool to interact with your system, your third-party system. Now, that could be a website, it could be a custom-written application. The application could exist on an on-prem server, for example. I mean, just as long as you have access to the URL, you could get to it. So really, that's the key criteria here, is that you need to be able to get access to that URL to be able to interact with the computer service. So the reason why this is a pretty valuable capability is because what we find when we're dealing with different application programming interfaces, in many cases, especially with legacy systems, there is no API available, at least a programmatic API. And so what we would consider here is that a UI is the API. So by that, what I mean to say is that if we can understand the screen progression on how to get information out of a system or maybe information into a system, we can train the agent to recognize the screens and the input patterns and the output patterns. And that then becomes the quote unquote API, right? Is just simply understanding the screen configurations and being able to put data in and get data out of the screens. Once that data is extracted out and it's brought into the agent, we can then turn around and do other things with it. We could update other systems. We could engage other MCP servers. We could use the M365 connectors to inform people through Teams or through email or whatever. So this is a really high-level example of a computer using agent. We see on the far left here, we start with the user entering a prompt, a typical conversational agent interface. Based on the prompt, then the CUA will take a screenshot of the target system and determine in kind of an action based on the prompt and the state of the screen. So there's a lot of reasoning that goes on back and forth between the agent and the prompt with regards to trying to get a successful completion, if you will, of a particular step that's given in an instruction set. And then moving over, the action then gets executed on the computer, right? And then the process starts all over again, because generally speaking, a prompt is going to be combined with an instruction set. And you'll kind of see this when I show you a demo. And so the action gets performed on the far right, and then the agent will go to the next instruction in the instruction set and try to perform the next operation. And this cycle continues until the full instruction set is complete. So when we kind of peel back the inside of the computer use tool, we obviously have the authoring canvas, which is mostly revolving around the instruction sets itself. We have the human supervision. The human supervision is essentially being able to watch or track the screenshots that come through, and you'll see this when we run the demo. But basically, what you're wanting to do is you're wanting to supervise, observe, or evaluate what the agent is doing screen by screen to make sure it's performing the right actions. And so between human supervision and observability, you have the ability to do that. You can also add approvals or requests for information if the particular steps that the agent feels like it can't complete based on the particular situation. We have security, so you're able to store credentials. For example, if you have a system that either has a paywall or some kind of a required login in order to get beyond that security step, get the appropriate permissions and get into the application. So you can supply that as well. There is a machine layer because the computer use tool uses virtual machines. So there is an ability to connect to virtual machines that is built within the Copilot Studio. And then from an AI model perspective, you can select different AI models, whether it's a GPT 4.5 or 5 or 5.2 or whatever, those can be selected. So as far as the virtual machines are concerned, you have a couple of different options. You can use the hosted browser, which is available by Microsoft. So Microsoft does provide basically a machine pool that can be used. Or you can bring your own machine in situations where you want to have full control over your infrastructure. The bring your own machine might be the right process for you. There is a cloud PC pool which basically takes some of the advantages of each one of these and brings them together. So this is a little bit more like an elastic pool. So understand that, it's one thing to run a computer use agent in a single user kind of environment. Let's say you're doing some testing or something like that, right? But if you scale a computer use agent out and you've got, let's say, lots and lots of people now running the agent, what that means is that you have a need for having multiple virtual machines get spun up, because each virtual machine then will essentially support or correspond to a particular agent. So you need to have the ability to scale out through this PC pool idea. So you want to think differently, because what I'm going to be showing you is just kind of a one-off example of you building an agent, testing an agent, for example. But when you scale out, you're going to need to have some way of scaling those virtual machines out to support, depending on the number of users you have, the number of times that they run the agent, and so forth. So we talked a little bit about human supervision. So the computer use will reach out whenever it needs more information to continue. So again, the example here might be that it needs to, let's say, send an email. You can see over here on the far right, you see an email is being sent, an approval email is being sent on behalf of the computer use tool, and it's asking for an approval before it performs a particular task. The observability, you'll see this in action. So essentially, the agent will keep track of the session history. So if you ever need to go back and see what the agent actually did in a particular instance, it keeps screenshots. It keeps the value state of your variables and so forth, right? So you can go back and actually evaluate what has happened historically. And these audit logs are available or stored in Purview. We mentioned credentials here. Again, if you have situations where you have a secure login, for example, you can connect in credential store through Azure Key Vault or some particular built-in options in the Copilot Studio. So we'll take this credential and use it then, in this case, to log into a website. There's also some quality metrics here, which will give you some feedback with regards to time saved based on these particular operations. This is helpful when you're trying to determine or establish a return on investment within an investment that you've made with the agent, for example. And so generally speaking, what you'll do is you'll assess and establish how much manual time a particular process may take. And then based on that, and based on the number of uses and functions that get applied, the agent and the agent telemetry will keep track of time saved. So I'm just going to play a quick demo here. here's an example of a number of different instructions that could be used for different scenarios. You can see invoice processing, data entry, data extraction. The instructions, generally speaking, fall into a particular pattern. The first step would be to go to a particular URL. You give it some instructions in terms of, what you want it to do. In this case, like this first example here, you're asking it to set a date filter and then open the invoice PDF in a new tab, then go in and fill out a form. I think you can see there's a relatively high level because the reasoning is actually pretty good within the agent with regards to evaluating the instruction set and the screens that are provided. So again, the steps would be you want to add the computer use tool to the agent. Secondly, then, is you would configure the tool with a prompt. In this case, these would be the instructions. Thirdly, you would test the prompt with the real-time updates of the screenshots and so forth, just to evaluate whether it's performing correctly. And then finally, once you publish and put it in production, you'd view the run history with the activity feed. This would allow you to go back and evaluate what the agent actually performed. We have some other things here again, defining the control access. Here you can actually set exactly which websites and desktop apps the computer use tool can access or run. What you're doing here is you're setting guardrails to ensure that the computer use tool is not, loading an improper website, for example, to perform the steps against. Again, you can define credentials in situations where there's a secure wall going into your application or your website. And then there's the human supervision element where the agent will reach out if it finds it needs to get approval from a human. Just some different key scenarios. There's the data entry scenario where you're perhaps taking information from, let's say, in this case, a spreadsheet or some kind of a manual system, maybe a scan system or something like that, and you're wanting to actually input that data into a third-party system. You've got data extraction, which is sort of the reverse, right? You want to go out, you want to pull data out of that system of record, and from there, then you want to do that. You either want to transform it into another system, or perhaps you want to do some other analysis on it in M365. And then finally, this visual interpretation here. You may actually use it to generate additional reporting that the system of record may not have within it. So in this case, you could, for example, use the code, the Python code capability to generate visual interpretations, or perhaps you might extract it and put it into Power BI or something. Just quickly, agent flows. We talked just a little bit about this. Again, this is bringing the Power Automate function workflows into an agent. We talked about connectors. The intelligent approvals, again, this would be in situations where you need to have a human in the loop. You can add these as actions into your Power Automate flows themselves. Request for information is a little bit different than approvals. Here, what the agent flow is doing is it's asking just to get some additional information to help it complete the task. So you can actually differentiate between an approval and a request for information. You can execute agents. So in the case of a multi-agent architecture, if you want to actually delegate a task to an agent directly from within your agent flow, you can do that, as opposed to, let's say, allowing the orchestrator to do that for you. Prompt builder, we talked about here. This allows you to, again, provide further curation on the calls to the large language model to provide it more information, or maybe dynamically replaceable variables, those kinds of things. The model we talked about, again, you can choose from additional models from AI Foundry and so forth. So you've got quite an expansion here with regards to what you can do. These are just some different things you can do with prompt curation using a prompt tool. You can do pre-summarization, you can do transformation, you can do reformatting, data reshaping, creating charts, and so on and so forth. So the list is almost endless. I mean, whatever you think you can do with a prompt to generate an output is basically what you can do with a prompt tool. Document generation is a new agent that is available, which you can use again within your multi-agent orchestration to do things like generate Word and PDF documents from right within your agent. Again, we talked about this. This is the Python code capability, that being able to generate visuals. All right. Well, I'd like to just end this quickly by taking you through a real quick demo here. And this is a fairly high level one, but what it does do is it gives you some idea of what's possible. Let's see here. So as you can see, I'm in Copilot Studio. And what I have is an agent I created called an item finder agent. It's fairly straightforward here. If you look at the instruction set here, well, first of all, I'm using GPT-5. But down in the instruction set, I'm basically saying if the user asks for an item to find, run this tool. The tool is called computer use and supply the item being searched. So when I go over to tools, you can see here that I have a computer use tool here that I created. This is where I actually give the instruction set with regards to how I want the agent to interact with, let's say in this case, a website. So looking at my instruction set, I'm asking it to navigate to this particular website, which is a book website here. And then I'm saying use the item search. This is a capability on the website here to find only the items that match the item that I'm giving it in the prompt. If an advanced search is required, proceed with that function without requiring user confirmation. So here what I'm doing is I'm telling it if you need confirmation for some reason, in this case, running an advanced function, don't bother getting it from me. You're free to go ahead and do that function. Then I say click on the top item in the list to display the product detail page. And then what I'm trying to do is actually get the book category, condition, and price of the item. So that's really what I'm trying to extract out of the website. Okay, so what I'm going to do here is I'm just going to go ahead and test this so you can kind of see what this looks like. I'm going to say, okay, so I'm going to paste in my prompt here. So my prompt is find an item called the technological system by, and here's the author. Okay, so running my prompt now, and you can see the high level instruction at the agent level knows that I'm asking for it to find an item. So what it does is immediately engages the computer use tool in this particular session. Notice that it's updating a variable called item, and it is put in there the item that I'm actually searching for. So that variable now is available for use elsewhere in the agent. So this takes a little bit of time to run because what it's doing is the agent is through the tool, it's evaluating the screens that it's seeing. So what it's done here is it's actually spun up a virtual machine, okay? And you can see the screenshots there. And it's actually giving me a step-by-step, what it's doing. So it's going out, it's trying to open a browser session. Let me just magnify this here, so everybody can see it. So you can see here the screenshot is it's loading the browser. It's opening Edge. And now it's navigating to the website. Now, obviously, if this is running in production, in other words, so let's say that you've deployed this, you're not going to be seeing this. Nobody's going to be seeing it. What's going to be happening is the agents are going to be running really just kind of on their own in the background. Nobody's going to see this really. What you'll have is the transcription logs and so forth based on these different runs. But the reason why I'm seeing this from an observability perspective is because I'm basically testing the agent. And I just want to see how it's going to perform. So just understand that what I'm seeing here real time generally gets written to the conversation history of each individual instance of this agent running. So you can see sometimes it has to go into kind of like a retry mode here um, to actually get to the point of performing the steps here. Well, we've got about 5 minutes left in the meeting here. Um, so I was hoping to actually get a response here, but seems to be taking its time here on this. And again, this wouldn't be a real-time operation in production, just so everybody knows. What this is I'm just simply observing to make sure that the agent is operating properly. So I mean, as you can see, it's still actually in progress over on the left. So its progress is going to be based on, things like internet speed and performance and these kinds of things, as well as the VM that has gotten spun up to support my session. So there we go. Now we can see the web screen now finally has come up. So this is actually the book vendor website. So now it should be running the search based on what I've asked it for. Okay. And ultimately, what I'm wanting it to do is I'm wanting it to return the price. Okay, so there's the book right there. You see it, the technological system. So it found the detail page. So what it should return to me now is the price. I'm wanting it to scrape the price off there. Yeah, so the middle section is actually the transaction log that's being created and written out. Well, I'm just hoping this can finish here before our meeting ends. We've just got a few more minutes here, so. Well, the good news is that it did take us to the item screen, and I think it's just taking a bit of time. Oh, okay. So now it's gone from the item list screen you can see to the actual product detail page of the item that I've asked it for. Ah, there it is. Okay, so you can see it finally returned my result. It said, I found the book, The Technological System by Jacques Ellul. It's available as a used hardcover in fine condition for $75. Okay, so you may ask yourself, okay, well, what's the value of that information? It's a test, it's a sample, right? The idea, though, let's say if I was working with a third-party system, for example, this might be things like, vendor name, vendor number, um, overall, spend or, something like this, right? And I could get that information and then do something with it. I could I could use it in a workflow, or I could actually update a third-party system or something like that. So,
Yep. Thank you.
okay, thank you. All right. Well, thank you everyone for your time. Appreciate it. We'll just leave this screen up here for a minute. We're at top of the hour. So thank you, everyone. Happy holiday.
Thank you.
Thanks, guys.